Hey, welcome. So today we're going to be talking about some trig functions. Real quick, I need you to write these equations down onto your paper. Pause the video and write all of them down. There are 6. Okay, you should have them written down now. Woohoo. All right, so we've talked about the product rule, we've talked about the quotient rule, we've talked about the chain rule. Now we're going to talk about trig functions. So sine, cosine, cotangent, tangent, secant, cosecant. Really, though, we're just going to talk about cosine and sine, okay? So let's look at a sine graph. Okay, this top graph here is a sine graph. It starts at 1, well, starts at 0, 0, comes up to 1, comes back down to 0, down to -1, up to 0, up to 1, down to 0 again. Let's look at then over here we have a cosine graph. Okay, it starts at 1, comes to 0, -1, back and forth, back and forth. Let's look at what the derivative of a sine graph would look like, though. Okay, we're just going to use our imagination here. Now remember, a derivative graph is going to show us the slope at any point here. So if I'm looking right here at 0, 0, what is my slope, my gradient? It's 1, okay? My slope, my gradient is 1. Well, now that I'm over here, it looks like I'm flat. If it's flat, what would my gradient be? It would be 0. So right there we're going to be 0. Then we come down here, it looks like we're coming down. Looks like -1 or so. Okay. Then right here, it looks like we're flat again. If we're flat, that's 0. Then over here, it looks like we're coming up. If we're going up, that's going to be positive. Then we're at 0 again. And then we are at, let's see here, -1. So we're coming down. So if I connect these lines to see what it looks like, what does that kind of look like? Does that look like the cosine graph? Oh! Is a cosine graph possibly the derivative of a sine graph? Oh, maybe it is. Okay. So the derivative of a sine graph is cosine. That's so cool. All right. Well, what's the derivative of a cosine graph? Is the derivative of cosine sine? Well, let's draw a picture and see. Looks like we're starting at 0. Ooh, that's kind of like a sine graph. And then it starts going down. So right here it's coming down, so that's about -1. Then we're back to 0 because it's flat. Then it's 1 again. Then it's 0. Then it's -1. And then it's 0. Let's see here. Well, that doesn't look like a sine graph, but it kind of does. If you look, all of the zeros line up perfectly with the derivative of cosine and a sine graph. They line up perfectly. The only difference is your high points are flipped. Like they've been made from being positive to negative. If you look, here it's positive, there it's negative. There it's positive, there it's negative. Positive. Sorry, negative, positive. It's just been switched, so it's almost like it's a sine graph, but flipped. How do we flip something graphically? If we want it to flip, so if we have a parabola like this, which is x squared, how do I make it go upside down? Do you remember? I just make it negative x squared. Well, guess what the derivative of cosine is? It is negative sine. And here it's just cosine. All right, so here's your little cheat sheet. Whenever you take the derivative of sine, you get cosine. You take the derivative of cosine, you get negative sine. When you take the derivative of negative sine, well, remember, sine just switches to cosine, so everything else basically stays the same. Once you take the derivative of cosine, negative cosine, if you remember here, it went from positive to negative. So here if it goes from negative, it should go back to positive. So whenever you take the derivative of sine, it goes to cosine. Whenever you take the derivative of cosine, your sign also changes. So it goes from positive to negative or negative to positive. So it's kind of just a cycle that you keep going through. Yes, over and over and over and over and over. Okay, here are the graphs, derivative, 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 back to the top. So here we have a practice problem. We've got y equals the cosine of x. What would the derivative be? You can look at the little chart over there. It would tell us it's going to be negative sine x dx. Another really quick problem. We've got negative cosine of x. Well, what is the derivative? Remember, whenever you're taking the derivative of cosine, the sign changes. So if it was negative, it's going to be positive now. Cosine goes to sine x dx. All right, next one. Ooh, there's something a little bit different. There's more than just an x on the inside. Now, when you take the derivative of a cosine or sine function, another piece that you have to do is very similar to the chain rule. Okay? The cosine and sine functions are basically just chain rules. That's all that they are. You take the derivative, then you multiply it by the derivative of the inside. So the derivative here would give me negative sine 3x times the derivative of the inside times 3 dx. If you want to make this a little bit nicer, you could say negative 3 sine 3x dx, okay? dy equals. That's how you could write it if you wanted to be a little bit nicer. All right, we're leveling up a little bit. What would the derivative be? Ooh, what does negative sine derive into? Negative cosine. Times, well, not times, but then we still keep the inside the same. But then we have to multiply by the derivative of the inside, which is 8x plus 3 dx. Pause the video if you need to. If I'm going too fast, you can always pause. You can go back, rewatch. I'm going to do another problem. All right, we're getting a little bit different here. Now, instead of having x cubed or whatever inside, we have cosine squared. Let's look at what that means. That means, I'm going to erase this just a little bit. We've got negative 5 cosine of x squared. Okay? That's the equation that we're dealing with. As we look at this part right here is basically just the chain rule. So I've got negative 5. I'm going to bring down the 2, so times 2 times the inside, okay, cosine x, have to minus 1 from that to the first power, then times the derivative of the inside. What's the derivative of the inside? Well, the derivative of the inside in this case would be negative sine x, okay? If you want to go through simplify that, you can. You've got 2 negatives, that gives you a positive, so 10 cosine x sine x. What? Okay, guys, let's try this one. So, this time we have a square root. Herbert Smith, we don't know how to take the derivative of the square root. Sure you do. The square root is just the power to the 1/2. So this is really y equals cosine 3x squared to the 1/2 power. Okay? Well, if we take the derivative, this is kind of looking like a sine rule. You have something on the inside with a power. So we bring the power down. dy equals 1/2 cosine 3x squared to the negative 1/2. Remember, part of the chain rule is we now have to take the derivative of the inside. What is the derivative of cosine 3x squared? Well, the derivative of cosine is negative sine 3x squared times the derivative of the inside. What's the derivative of the inside? 6x. So if you want to know what the slope or gradient is at any point along this curve, this is the equation that you would have to use to figure that out. Okay? All right, if you think you've got it, give this one a try. Pause the video, see if you get it right. If you get it right, don't worry about the rest of the videos. If you get it wrong, watch 1 or 2 more. Okay, here we go. Here's the answer. You should have paused it. You should have tried it by yourself by now. So, here I'm seeing an exponent. So this is really going to be negative 4 sine 4x cubed plus 5x cubed. So it appears to be a chain rule that's happening. I've got something on the inside. I have a function on the inside. I have an exponent. So let's take the derivative. dy is going to equal 3 times negative 4, so negative 12 sine 4x cubed plus 5x squared. Remember, you got to subtract 1 from that exponent that we just brought down. Whenever you bring the exponent down, you have to subtract 1. Times the derivative of the inside. Well, the derivative of the inside is going to be cosine 4x cubed plus 5x times the derivative of the inside, because we took the derivative here. Remember, the derivative of sine is cosine, plus you still have to multiply it by its derivative, which is, let's see, 12x squared plus 5. dx. Run out of room there on that problem. That was a longer problem. That was a longer problem. All right, let's try the derivative here. So we've got 4 cosine squared of 6x squared plus 3 on parentheses. Well, let's see here. This is really going to be to the 1/2 power. So when I go through and take the derivative, and I get dy, that's going to give me, let's see here. If I take the derivative of cosine, that's going to be negative sine. So negative 4 sine square root of 6x squared plus 3. But what's the derivative of square root of 6x squared plus 3? Remember, that is technically to the 1/2 power. So when I take the derivative there, that's going to give me negative 1/2. I'm going to get a 1/2 in front. And 12x. I can simplify that a little bit. That gives me negative 2 sine square root of 6x squared plus 3 times 12x to the negative 1/2 power. Okay? dy dx. Whew. All right, I'm going to throw another one up here. I want you to give it a try. All right, this one's a little tricky. See if you can do it. All right, you should have paused the video. You should have the answer by now. Here we go. So the first thing I'm going to do is I'm going to rearrange how this little 2 is written, the little exponent 2, okay? So I've got dy equals, well, not even before I do that, negative 3, I'm going to have sine of all this, 6x cubed plus 3x cubed squared, okay? So I take the derivative, I'm going to bring that 2 down. That's going to be the first thing I do. I get negative 6 sine 6x cubed plus 3x cubed. Then the 2 becomes a 1. Then we're going to multiply that by the derivative of the inside. What's the derivative of sine? It's cosine. Six x cubed plus 3x. Okay, that's also cubed. Now I got to take the derivative of this inside. Ooh, this looks like another chain rule. It looks like it's just chain rule on top of chain rule on top of a chain rule. This is insane. So, derivative of the inside, well, I got to bring the 3 down. Okay, which leaves me with the 2. So 6x cubed plus 3x squared. But now I have to take the derivative of the inside. That's 6x cubed plus 3x. That leaves me with, ooh, I gotta multiply that now by 18x squared plus 3 in parentheses dx. Do I want to go through and clean this up a little bit? I could go through and clean it up just a tiny bit. It's not gonna do a lot. I'm going to take this 3 right here and this -6 and multiply them. So my dy is going to be -18 sine 6x cubed plus 3x cubed to the first power. Technically, I could get rid of the first power. I can get rid of that parenthesis and this parenthesis. Times cosine 6x cubed plus 3x cubed. And technically I don't even need that bracket anymore. Okay. Actually I do. Because it's just this that's being cubed, not the cosine. Times 6x cubed plus 3x squared times 18x squared plus 3 dx. Oh my goodness, that was a long answer. Oh my goodness. It's probably the longest answer you've ever gotten in a math class. Okay, I'll do one more problem. Again, if you've got it, if you don't need any more help, turn the video off. Actually, don't turn it off quite yet. There's one little picture that you need to get at the very end. All right, here's the last problem. Give it a quick try. Yes, this is the last problem, don't worry. Okay, you should have the answer by now. If you don't, pause it. So, here we go. Not that you should have the answer without pausing it, but you should have paused it to get the answer, okay? Here we go. So, we are going to take the derivative here. Now, something to keep in mind, this is technically to the 1/2 power. So, when I take the derivative, I get dy equals negative sine square root of 3x squared plus 2. Then I have to take the derivative of the inside. The inside is, remember, 3x squared plus 2 to the 1/2. So when I take the derivative, that gives me 1/2 3x squared plus 2 minus 1, that's negative 1/2, times the derivative of the inside, which is 6x. If I wanted to go through and clean it up just a little bit, I could. 6 times 2 is 3, so negative 3x sine times sine of square root 3x squared plus 2. Then I've got my 3x squared plus 2 to the negative 1/2. That would be a little bit more simplified, looking a little bit nicer. And don't forget the dx. Guys, even sometimes I forget to put dx on there. Dx does signify that it is the derivative. Okay, the picture that I said, I'm actually going to put at the beginning of this video. So the very beginning of this video, there's a picture, might be even a quick little clip that I do, of a couple of these formulas that you need to remember. Okay.